Hello humans, I'm Mr. King.
Yo, boys and girls, good to see you again. Alright, okay, let's go into this topical exam questions on organic chem. Alright, so first, if you look at this, isn't it? Alright, so what is the general formulas of alkene? Okay, alkene, CnH2n, that's it. Okay, and next, so what will be the color change, okay, when alkene is bubbled through bromine? Remember, you see, now how do you test for the presence of alkene again? We test with aqueous bromine or bromine water, and the color change, it would be from orange to colorless. And think about this, yeah? The colors of bromine water, okay, a better color to put is always orange in color. Okay, like why? Okay, it is to differentiate between the colors of bromine water and iodine water. Okay, iodine water it is brown in color, and bromine slightly lighter in color, okay, which is orange. Okay, so this is the reason why. Okay, remember, yeah, colors of bromine water, okay, orange. So orange to colorless, okay, to show that there is addition reaction. Okay, and what is this types of organic reaction? Addition reaction. Okay, then next. Okay, how do you name the acid again? So remember, you see, whenever you are given with formulas or structural formulas of acid, isn't it? Okay, first, always identify the functional group, which is the COO functional group. Okay, hydrocarbon that is attached to the O in COO, it belongs to the alcohol part. So you see, hydrocarbon that is attached to the O in COO, see, it belongs to the alcohol part. So you see, alcohol part, how many carbon here? 1 carbon. Acid part, 1 carbon. That's it. Alright, so this is how you identify the names of the ester. Okay, and empirical formula. So what is empirical formula again? So empirical formula, it shows the simplest whole number ratios of the molecular formula. So same thing, first identify the molecular formula for this compound. 2 carbon, 1, 2, 3, 4 hydrogen, and 2 oxygen. So molecular formula C2H4O2. Okay, simplify with 2. So eventually you get CH2O, okay, which is the empirical formula. Okay, and then next, okay, draw the, so you see, ester, it can be made by reacting two organic compounds together. So, see, which is this is so from methanol and methanoic acid. That's it. Okay, from methanol and methanoic acid. Okay, then, okay, how do you define the term isomer again? Okay, isomer means compound with the same molecular formula but different structural formula. So those that are highlighted, these are the keywords that you have mentioned, okay, in order to get full marks. Okay, and then what is the carboxylic acid, which is a structural isomer to ester Y? Okay, see, they ask you carboxylic acid as isomer to Y. So you see, in Y, there are total how many carbon? 2 carbon. Okay, and what is the ester with 2 carbon called? Ethanoic acid. So you see, if you look at the molecular formulas of ethanoic acid, right, okay, it is the same as this. Okay, because they are isomer. All right, same carbon. Okay, and then next, okay, general formulas of alkane, CnH2n plus 2. Okay, and I say this is the examples of substitution reaction. Okay, condition either for substitution reaction, UV light or ultraviolet light. Yeah, and then what is the names of these types of organic reaction? Substitution reaction. Okay, one more thing is to recap, right? During substitution reaction, okay, it always form two products. Okay, so-called organic products and inorganic products. All right, remember, organic compound means compounds that contains carbon. All right, inorganic compounds that doesn't contain carbon. So if you refer back to this equation, right, see, substitution reaction always forms two products. See, this one with carbon, so this is so-called the organic products. This without carbon, so this is so-called the inorganic products. All right, so please think about this. Okay, and then so one product is chloroethane, which is this. So what is the another product? So how do you name HCl, which is in the forms of gas? So it is called hydrogen chloride. Okay, one more thing you see, if you put hydrochloric acid, okay, 100% no marks will be given. So what's the difference? Hydrogen chloride, they are in the forms of gas. Hydrochloric acid, they are in the forms of aqueous solution. All right, think about this. Okay, so next, what is the general formulas of carboxylic acid? So carboxylic acid, CnH2n plus 1 COOH. And what is carboxylic acid? Why? Only one carbon, methanoic acid. Okay, and molecular formula, so just calculate. So there are total how many carbon, hydrogen, oxygen. Okay, molecular formula. It shows the exact or actual numbers of atoms of each element in the compound. Okay, then next page. Okay, you are asked to draw ester. Okay, so you see carboxylic acid Y, so carboxylic acid Y, methanoic acid. Okay, it reacts with propanol. So propyl methanoic. Okay, always start with COO first. Okay, start with COO. Remember, as mentioned just now, hydrocarbon that are attached to the O in COO, they all belong to the alcohol part. See, alcohol, how many carbon? 3 carbon. Okay, acid, 1 carbon. 1 carbon, and it just place one more H over here. That's it. Okay, and what is the another product forms when carboxylic acid reacts with alcohol? Carboxylic acid reacts with alcohol to form ester and water. Yeah, then what is the ester, which is isomers of ester Z? So you see, how do you identify the isomers of ester again? Okay, you play around with the numbers of carbon, okay, at both the acid and alcohol part. So if you look at this example, right, see, ester, they are made of acid and alcohol part. So for this compound alcohol, how many carbon? 3 carbon. Acid, 1 carbon. So total you have 4 carbon. All right, so isomers for this season, it can be like what? Okay, acid part 3 carbon, alcohol 1 carbon, or acid 2 carbon, alcohol 2 carbon. See, total there are 4 carbon in the compound. So which means answer it can be ethyl ethanoic or propanoic. Okay. All right. Okay. And then carboxylic acid has isomers to ester Z. So they are total how many carbon? 4 carbon. So carboxylic acid with 4 carbon, butanoic acid. Okay. All right. Okay. Next. Give me this. Okay. Addition polymers. So state the numbers of state the numbers of monomers unit they are needed. Yeah, to make this. So you see, there are total how many repeat units over here? Remember, see how addition polymerization are taking place again. Okay, by breaking the carbon to carbon double bond. Okay, and you need only 2 carbon to form a double bond. So it always takes just 2 carbon to form 1 repeat unit. So there are total how many repeat units over here? 2. Okay, and one more thing you see, you only put bracket and N when you draw the general formulas of the polymers. Okay, so whenever you draw polymers with a specific number of repeat units, okay, you do not need to put bracket anymore. That's why you see there's no bracket N1. All right. Okay, and then you're asked to draw the structures of monomers. Okay, so you see given here, show all the atoms and all the bonds. Okay, so you see initially this is how it looks like what? Initially, this is how it looks like. So basically, just copy back everything. Okay, so you see, this is 1 repeat unit. Okay, initially, this is how it looks like. C2H5. But you can see, you place back the double bond in between these 2 carbon. But you cannot leave your answer like this. Because as mentioned here, show all the atoms and all the bonds. So you have to open up everything. Okay, doesn't matter if you put it on top at the side. Okay, because it is still attaching to the same carbon. Okay, doesn't matter you put it on the top, bottom, or side. It is still the same. Yeah, because we look at which carbon it is attaching to. Okay, so C2H5 what? So 2H5. Okay, and how do you name this? So it's a double bond attached to the first and the second carbon. Okay, it is called but1-ene or butene. Okay, they are both the same. Alright, so this is how the drawing looks like. Okay, and next one, empirical formulas of these polymers. Okay, look for the molecular formula, simplify, you will get CH2. Okay, and then next, I see. Proteins are broken down into amino acids. So name the types of reaction in which proteins are broken down into amino acid. It's called hydrolysis. Okay, and what are the two substances? Okay, or two different substances? Okay, they are needed to carry out hydrolysis. Okay, acid and heat and enzyme. Okay, so these are the two different conditions. Okay, they are needed. Then, okay, what is the process that can be used to separate the amino acid? So how can we separate all the natural compounds from one another? Through chromatography. Yeah, and what is the types of substance that's used to detect the amino acid? So after you carry out chromatography, isn't it? So how do you identify it? Okay, like all the component produced, you use locating agent. See, they ask you, name the types of substance. You cannot give the names of the locating agent like what? Nin hydrate. No. So answer, you cannot put nin hydrate because they're asking for types of substance. If they ask you name the substance, then answer it would be nin hydrate. Okay. So and then symbols of value. Okay, so it will be the RF value. Okay. So next one. Okay, examples of synthetic polyamide nylon. So please make sure you remember the examples of synthetic and natural polyamide and polyester. Okay, popular questions in the exam. Okay, and then what are the two functional groups? Okay, they are needed. Okay, so to form polyamide, okay, there's one monomers with COOH functional group, which is called carboxylic acid. Another one, it will be NH2, which is called amide. Okay. So next. Oh yeah, one more thing is COOH. Remember, you see there's always one monomers with COOH one. Another one is what? NH2. Alright, so COOH, carboxylic acid. NH2, amide. Alright, okay, next one. Okay, general formula for carboxylic acid. Okay, and you're asked to draw carboxylic acid with 3 carbon. Okay, COOH. Okay, and then the remaining 2 carbon. Alright, so this is how to draw carboxylic acid. So what is ester X? Yeah, so how do you name the ester easily again? First, always locate the COO. Okay, shortcut. Locate COO and hydrocarbon that's attached to the O in COO. It belongs to the alcohol part. See, alcohol part, 1 carbon. Acid part, 1, 2, 3, 4 carbon. That's it. So you see, alcohol part, 1 carbon. Acid part, 4 carbon. Okay, and give the names of the carboxylic acid and alcohol that reacts together. Okay, butanoic acid and methanol. Alright. Okay, next one. So what is reaction 1? From sugar, okay, to ethanol. So fermentation. Okay, and then reaction 2, you see, what is the reaction? They will produce CO2 and H2O. So it will be complete combustion. Okay, so it's the equation looks like this, and please make sure, okay, you need to know how to construct a balanced chemical equation. Okay, so please make sure that it is a balanced chemical equation. So what is alkene A? Let's see, A is formed from what? Like A forms ethanol. So alkene A will be ethane. Okay, it is called addition reaction. Remember, alkene reacts with steam to form alcohol. Okay, and what's the condition needed for this addition reaction? So-called hydration again. Okay, reagent state. One more thing you see, reagent you cannot put water. If you put water, no marks will be given. Okay, it can only be steam. Why? Because if you look at the condition needed, so what are the condition needed? Temperature 300 degrees Celsius, catalyst phosphorate, pressure 60 atm. So you see, given at this temperature, what is the state of H2O? Gas, isn't it? H2O in the forms of gas, what is it called? Steam. All right. And then A converted into B, alkene into alkane. Okay, through hydrogenation. Okay, so reactants, hydrogen. Okay, with the condition, okay, high temperature and nickel catalyst. Okay, and what's the general formulas of alkane? CnH2n plus 2. Okay. Okay, and then next one. So see given here, alcohol is oxidized. Okay, so you see with acid and one other reagent. So what is the another reagent? So you see given here, oxidize. So how oxidation is carried out again? You need oxidizing agent. Okay, and what are the examples of oxidizing agent again? Acidify, potassium manganate 7, or acidify, potassium dichromate 6. Alright, so why there's acid over here? You see the presence of this acid, right, it is to acidify the solution. So what is the another reagent? So it can be potassium manganate 7 or potassium dichromate 6. Okay, so I say for this isn't a kit, you do not need to mention the word acidify. Even if you mention isn't a kit, it doesn't matter as well. Okay, because already mentioned here, acid with another reagent. So the purpose of this acid, right, it is to acidify the potassium solution. Okay, and then what is compound C? See, alcohol get oxidized, why isn't it? So to becomes carboxylic acid. Okay, and you're asked to draw. Okay, so ethanol becomes ethanoic acid. Okay, and then given with this, so okay, there are total how many water molecules that will be produced during this condensation polymerization? Okay, it is 3. Like why is it 3? So how condensation polymerization is taking place again? By removing H2O. Okay, and how H2O is formed again? From H and OH. Okay, so easy. Remember, like what? How it works again? Can remember you said when the COH isn't a K, another one it looks like this OH. Okay, so you see you always remove the OH from the COOH part. So OH get removed, OH get removed. Another one you remove just the H. So you see OH and H they get removed to form H2O. And then eventually this CO and O they join together. So see to form COO linkage. So which means you see here it shows that for the formations of every single linkage, it will produce one H2O. One linkage here, another linkage here. So how many water molecules are formed? 3. Okay, so this is how it works. Okay, and then the structures of two monomers, like the one I mentioned just now. Okay, and you have to do it accordingly. See, given here, the one that's colorless attached to C double bond O. The one that's colored attached to O. Okay, so you just pull back the OH and H. Okay, and one more thing, see, you cannot draw the COOH like this here. Cannot, no marks. Marks will be deducted. Why? Because as mentioned here, show all the atoms and all the bonds. Okay, that's why I have to open up. Okay, to show the bond between the O and H. Okay, so this is how it looks like. So what types of condensation is this? See, produces COO, polyester. Okay, next one. So there are how many different types of monomers here? See, they're asking you numbers of different types of monomers. So you see, first, there are how many repeated units over here? Okay, 1, 2, 3. But if you look easier, you see, all 3, they are the same. Okay, you see, there are 3 repeated units of the same monomers, and they're asking you, okay, there are how many different types of monomers? Only one type. See, they're all the same. Okay, and then Okay, you're asked to draw the monomers. Yeah, same thing, you see, this is one repeat unit, isn't it? Okay, you're asked to show all the atoms and all the bonds. Okay, you have to do it accordingly. So you see, initially, how does it look like again? So if you copy everything exactly the same, right? Okay, see, you put back the double bond in between these two carbon. C, and then CH3, H, CH3. But you cannot just leave the answer like this, because as mentioned here, show all the atoms and all the bonds. So you have to open up. Yeah, same thing. It doesn't matter you draw it on the top or at the side. It is still the same because it is still attaching to the same carbon. And so CH3 bring to the side, CH3. Another one bring to the side becomes CH3. Okay, so eventually, how do you name this compound? All right, see, where is the double bond? See, the double bond is attached to the second and third carbon. So that's why it's called but2ene. Okay, so one more thing is here, if you draw butene isn't okay, then it is incorrect. So if it's butene, right, it wouldn't form compound that looks like this. Yeah, so you see that C here, that C here, I see. If you refer to the example that we just done, I think there's one with butene, isn't it? Yeah, I see butene. So you see, the one butene, you see, it forms compound with a different arrangement of carbon. Yes, it's different. Okay, so you see, always do it according to the question that's given to you. Okay, and then what is the chemical process that is used to make monomers that form Z? Okay, so what is the process that will produce alkene? So alkene is formed from cracking of alkane. Okay, so next one. Okay, general formulas of alcohol. Characteristics. Okay, other than having the same general formula, what else? Okay, same functional group, similar chemical properties, what else? Okay, one member to the next member differ by a CH2 unit. Or physical property changes in a predictable way. Okay. Okay, and then yeah, you're asked to draw like what? Isomers of propane 1-or. Okay, so this one, OH attached to the first carbon. So isomer, OH attached to the other carbon, like second carbon, propane 2-or. Alright, this is the only answer. Okay, so then, so what's ester X? Same thing as mentioned just now. First, always identify the COO. Hydrocarbon that's attached to the O in COO belongs to the alcohol part. 2 carbon. Okay, 4 carbon. Okay, and then name the alcohol and acid needed. Okay, next one. So you see, reactions that form short chain alkene and alkene from a long chain alkane, cracking. Okay, so next you see given here, see you're asked to write the chemical equation for this. So you see given here, this alkane contains 10 carbon, and it undergoes cracking to produce just like what? Just ethane and ethene as the only products, that's it. So produces just C2H6 and C2H4. Okay, so eventually, how does it look like? It looks like this. Okay, so 10 carbon alkane. Okay, CnH2n plus 2. Okay, you get this. So it produces just these two products, that's it. But always make sure that it is a balanced chemical equation. So is this equation a balanced equation? No, it is not. Okay, so how to balance it? Da-da-da-da-da. Okay. So another product form. So this is an example substitution reaction. Okay, so from this organic product, so another product produced, it will be hydrogen chloride. Remember, yeah, you cannot say hydrochloric acid is incorrect, okay, because this HCl is in the forms of gas. Yeah, and what's the condition needed for substitution reaction again? UV light or ultraviolet light. Okay, and then what is this addition reaction? Define the term addition reaction. Reaction that produces just one product. So it's called addition reaction. It means all the reactants, okay, they are added up together to form just one product. Okay, yeah, and then, okay, given all this, so what is the name that's given to families of organic compound with similar chemical properties? Okay, it is called homologous series. Okay, and why they have similar chemical properties? Because they have same functional group. Okay, remember, you see, functional group, right? It is the groups of atoms that determine the chemical properties. Okay, and then so you see, what is all this kind of general all these kinds of formula called? Okay, so it's called general formula. Okay, so what would be the end in this butyl propanoate? So you see, this alcohol, how many carbon? Butyl what? 4 carbon. Propanoate 3 carbon. So total 7 carbon, isn't it? And N stands for numbers of carbon. So N equals 7. Okay. Okay, and then so what is the technique that can be used to separate all these esters from one another? So basically, right, okay, say keywords given here liquid. So how can you separate liquid of the same kind from one another? Okay, based on different boiling point. Yeah, so the method, it will be fractional distillation. Okay, and then name this substance and draw the structure. So you see, given here, okay, all 4 ester, right, see different alcohol with the same substance, same acid. So the acid, propanoic acid. Yeah, so what's the alcohol needed to make this? Methanol. Alright, so it's not that hard. Okay, organic chemistry is actually quite easy. Okay, yeah. So you see, substance with the same molecular formula but different structure. Yeah, structural isomers or just the word isomer. Okay, so what are the 2 esters with the same molecular formula as this? So you remember, how do you identify the isomers of ester? Okay, you play around with the different numbers of carbons at both the alcohol part and acid part. See this one, alcohol 3 carbon, acid 3 carbon, total 6 carbon. So it can be, see, alcohol 1 carbon, acid 5 carbon, total 6 carbon. 5 carbon, 1 carbon, total 6 carbon. Okay, and there are also other answers like what? It can also be like 2, 4, okay, or 4, 2, okay, ethyl butanoate or butyl ethanoate. Okay, so there are 4 different answers for this. Okay, okay, and then so you're asked to draw the polymer. Remember, you see condensation. Take away H2O. All right. Always remove the OH from the COOH part and remove the H from the OH part. And then you join them together. Okay, one more thing you see, when you draw polymers, okay, please make sure that both the ends will always end with extended bond. Alright, it is to show that it is still joining with some other monomers. Okay, it is a must. This is how you draw polymers. Okay, both the ends always end with extended bond. Okay, so what types of this polymerization? Condensation. Okay, and name a polyester, perilene. Okay, yeah, so this is how organic chem looks like. Again, so hope you guys enjoy it, and then thanks. Okay, sayonara, bye.